Okay, here's our next question for out of question 1, and here we're also looking at a possible excellence question where we're asked to solve this, well, not solve this equation, but find a value of a that will make this equation work. And all we're told is that the difference between the solutions is 10. So that just means if we subtract one solution from another, we get 10. So let's start by making this quadratic equal to 0 on one side by subtracting 30 from both sides, and that will give us x squared minus ax minus 24 equals 0. And so we're going to factorise this into two sets of brackets. So I'll put x at the start of each bracket, and we're looking for two numbers that multiply to negative 24 and add to a, but we're not sure what a is. So let's list all the factors of 24. So I've got negative 24 and 1, 24 and negative 1. We have 12 and negative 2, and negative 12 and 2. So here we've got 2 with a difference of 10, which is what it tells us that our equation has. So we're going to have 12 in one set of brackets and 2 in the other, and these need to multiply in a way that we end up with a negative coefficient for x and negative 24 overall. So the biggest number would have to be negative to make that work, and the other number would be positive. And so our two solutions are x equals 12 or x equals negative 2. Now the question is actually asking for the value of a, so we need to put these values back into our original equation to see what a is. I'm going to put in negative 2 because it's a little bit smaller, so it's going to be easier to work out, and I'm going to put it in for both of those x values. So that gives us negative 2 squared minus a times negative 2 minus 24 equals 0. So negative 2 squared is 4. Negative a times negative 2 is positive 2a. We've still got minus 24 there equals 0. So that's 2a minus 20 equals 0. Adding 20 to both sides, I'll bring our next step of working up here. We've got 2a equals 20, dividing both sides by 2, a equals 10. And that's what the question is asking for. So a relatively straightforward question there for excellence, but nevertheless really worth having a crack at some level. Okay, question C, a square room, well, I'll let you read through that, and but I'll jump straight into it more or less. But a square room and a hallway to have carpet laid on the floor, and we've got this much area of carpet to cover the hall and the room. The width of the hallway is 6 meters less than the length of the room, and the hallway is 5 meters longer than the length of the room. So I'm just going to draw a picture to help me understand this. So I have a square room, and then I have a hallway which I'm assuming is rectangular because it doesn't say it's square. And what I think I'll do here is I'll just say that the room is x meters by x meters, because I don't know what it is yet. But I do know that the width of the hallway is 6 meters less than the length of the room. So if this is x meters long, then this length is 6 meters less than that, which is x minus 6. And we're told that the length of the hallway is 5 meters longer, so that's going to be x plus 5. Okay, now we're told that all of this area adds up to 123 meters squared. So 123 meters squared. And so let's work out an area for each of these. So for the square room, the area is going to be x times x, which is x squared. And for the hallway area, that's going to be x plus 5, the length, times the width, which is x minus 6. And so we can use all of this information to form an equation. So in other words, x squared plus the area of the hallway is equal to 123. And this is an equation that we need to solve. So let's expand our brackets here. So we've got x squared plus x squared minus x minus 30. Let's collect our like terms. So we've got 2x squared minus x minus 30 equals 123. And it's a quadratic, so let's make one side equal to 0. And that gives us 2x squared minus x minus 150, and that's equal to 0. So now we need to factorise. Now this does look a little bit intimidating to factorise, but if we use a bit of common sense, it actually works out really nicely, because we have to have 2x and x in those brackets, because that's the only way we can times to get 2x squared. And then we're going to have two numbers that are really close together, in fact only different by 1, and they're going to multiply to 150. So I happen to know that, 12 squared is 144, so I'm going to take a guess here that my two numbers are going to be something like 12 and 13. So something that's relatively close, although I've got to also keep in mind that it's going to times with 2x, so they're going to be different once I double them. So anyway, let's list some factors of 150. So let's see, we've got 15 and 10. We've also got 20 and 5. We have what else are we going to have here? We'll have 30 and, sorry, that should be, that 20 and 5 isn't right. 30 and 5 is what I should have had. And we could have 3 and 50. And what else can we have here? I feel like I've made a mistake because this is too hard. Let's look back here and see if we've made any mistakes. Okay. Yes, we have. That should be 153. Okay, so 153, well, there's not going to be many numbers that go into that. But keeping in mind that we can't use a calculator here, one of them must be probably below 10. So 153, let's try dividing some numbers into it. So 2 doesn't go into it. 3 goes into 51 times. So that could be a goer, although 51 is also divisible by 3, which means 9 would go in. So let's try 9, see what we come up with. So 9 goes into 15, 1, carry the 6 into 63 7 times, so 9 and 17. Oh, and if we double 9 we get 18, and that's 1 different from 17, so that's going to be our goer. So let's put that in. We're going to have minus 9 and positive 17, and those give us our two possible solutions. So either 2x plus 17 equals 0, or x minus 9 equals 0. So 2x equals negative 17, or x equals 9, dividing both sides by 2, x equals negative 8.5. Now one of these answers makes sense and one of them doesn't, so let's go back to our question. Solve an equation to find the length of the room. Well, can we have a negative length of a room? No. And so this is our answer. So the length of the the room will be 9 meters. And that's a really good excellence question there. And that will do, I think.